Assignment number 4 is talking about mesh, superposition, and Thevenin, and Norton, and maximum power as well. Before we start talking about the assignment, I would like to talk about the tutorial first. And after that, I'll go back to the assignment and see each problem. If you have any question, I'll answer your question. But before I start talking about the tutorial and the assignment, I'd like to remind you by what we studied. If we are talking about mesh current method, mesh current method is saying assume current in each mesh, and then say summation the voltage for each mesh is equal to 0. So mesh current method is similar to KCL and KVL, but it's more easier because from the beginning, you are defining the current in each branch without saying summation the current for each node is equal to 0. Am I right? That's why it's more easier, but it is the same like KCL and KVL. So if I asked you to use mesh and you use KCL and KVL, I will not penalize you. That's fine. I'll accept it as well. Okay? If I ask you to use mesh and you use KCL and KVL, I'll accept it. Because it is the same. The only difference is, and instead of saying summation of the current for each node is equal to 0, you are defining the current for the loop is the current for the branch that's connected to that loop only. And based on that, I don't need to say summation the current for each node is equal to 0. The second method, which is superposition. For superposition, I can use it to find the current or the voltage for any branch by using only one source and remove all sources. Again, removing voltage source means substitute it by short circuit, and removing current source means substitute it by open circuit. So what is needed is to remove all sources and use only one source and find the voltage or the current due to that source at a specific branch that I asked you about. And then remove that source and use the other one and remove the other one and use the third one and so on, and add up all of those based on their signs. This is superposition. My recommendation to you is don't use superposition unless I ask you, because you are going to solve the problem many times based on the number of sources. Next term, if you studied with me circuit analysis, I'll talk about superposition again while I'm talking about harmonics. If we have harmonics in the problem, I have to use superposition. But this is another story. But for our level right now, no need to use superposition unless I ask you. The third method, which is Thevenin or Norton. When should I use Thevenin or Norton? For one of three conditions. Number one, I asked you directly to find Thevenin or find Norton. Number two, I give you variable resistor and I asked you to find the value for that resistor for maximum power. You have to find Thevenin equivalent first, and then you will say for maximum power transfer through that resistor, the variable resistor should be equal to R3. Number three, if I give you resistor with different values, and I ask you to solve the problem many times based on different values for the resistor to calculate the current or the voltage for that resistor. At that time, it's better to find Thevenin equivalent, right? This is what we studied in case of Thevenin, Norton, maximum power, superposition, and mesh. Let me start from the beginning to talk about all different theories that we covered. Number one, KCL and KVL and mesh, I'm considering both of them could be used for solving any problem. Node voltage method, it could be used for solving any problem, right? So those three different methods KCL and KVL, mesh, and node voltage method could be used for solving any problem. Any problem? Yes. If I didn't ask you, you can use any one of them. That's okay. If I didn't ask you to use a specific method. What about the current divider? No, current divider is not a method. It is identity. I'm using it for simplifying one or two steps, right? What about the voltage divider? It is identity also. I'm using it for simplifying one or two steps for the problem. What about source transformation or source conversion? If you are seeing source conversion is more easier to be used for solving the problem, okay, you can use it. But if you asked me, I don't recommend to use it unless I asked you. Why? Because sometimes I give you a specific configuration of the problem. And if you try to use source conversion, maybe you will change the configuration of the problem. And maybe you will forget a specific unknown or a specific branch because you changed the configuration of the problem by using source transformation. Are you seeing what I'm talking about, guys? Okay. Now, Thevenin, Norton, maximum power, I told you when should I use them for one of three conditions. If I asked you directly to find the maximum power, if I gave you variable resistor, if I asked you to find Thevenin or Norton or maximum power in a specific circuit. So it's very easy to decide which method should I use. Superposition, I'm not recommending to use it unless I asked you, but if you would like to use it, that's fine. I don't mind. Let us see right now problem number 1 in the tutorial. For problem number 1, I gave you that circuit. What is needed? I asked you for that circuit to use mesh current method to solve for I delta. Where is I delta? It is this current. Find the power delivered by the independent current source. Where is the independent current source? This guy. So I would like to find the power delivered. For finding the power delivered in this guy, I have to find the current in this guy. Then he asked, he is asking me about the independent. So I have to find this voltage first. And then multiply V times I can find the power. And then he asked me to repeat the problem by finding the power delivered by the dependent source, which is this guy. So I have to find the current in this guy. In all cases, I have to find the current in each branch to be able to find the power across this guy and I delta, and also the power across this guy. So let us draw that problem and start solving it. He asked me to use mesh methods. So what am I going to do? I'm going to assume current in each mesh. So I'm going to assume current in this mesh, and I'm going to assume another current in this mesh. Am I right? This is the direction for the current, and this is the direction for the current. What is the current for this mesh, guys? It is 5 milliamps. How did you know? Because the mesh current is the current for the branch that's connected only to that mesh, which means the current for this guy is equal to 5 milliamps. What about the current in this guy? I don't know, because I don't know the current in this branch. So I'm going to assume it, like my friend said, it's I1. Then I will say summation, the voltage for each mesh is equal to 0. So if you try to look to the problem, I have current in this guy, which is 5 milli. And I have current in this guy, which is I delta. But I delta is equal to what? It's equal to 5 milliamps minus I1. So I can write from the beginning that here, I delta is equal to 5 milliamps minus I1. Then I'll say summation, the voltage for each mesh is equal to 0. Which mesh should I use first? Should I use this mesh first or this mesh first? For I1, why for I1? Excuse me? Okay, why I shouldn't use this guy? Yes, because I don't know the voltage across 5 milliamps. So if I started by saying summation and the voltage here is equal to 0, I have to assume this voltage first. But I don't like to see many unknowns. I'd like to write the minimum number of unknowns in my equations as much as I can. So I will start writing this equation first, and I'll see if I can solve it. That's okay. If not, I'll write the other mesh equation. So imagine that, for example, this mesh is number 1. So summation V is equal to 0 for mesh 1. Summation V is equal to 0 for mesh 1. If you still remember, I told you that if you would like to write the mesh voltage, you will say, here we have I1 in this mesh. So I will say I times all resistors connected in that mesh. So I1 times all resistors, summation, minus the other current times the common resistor between these two mesh. Am I right? Why I'm saying that? Because if you try to look to this guy, if I assumed that the current in this guy is upward, so I can say the upward current is equal to I1 minus 5. Right, guys? So the voltage drop across this guy is equal to 5 minus I1 times 5.4 or I1 minus 5 times 5.4. In all cases, since you assume the current in the same direction for all mesh, the common branch has the difference of the current between two current mesh. Am I right? That's why I'm saying if you would like to find directly the voltage for this guy, I will say I1 multiplied by summation all resistors. What are those? 5.4 plus 1 kilo plus 2.7, all of them multiplied by 10 to the power negative 3 minus 5 times 10 to the power negative 3 multiplied by the common resistor, which is 5.4 times 10 to the power negative 4. And don't forget that you have a voltage source here. So the voltage source value is 150 I delta. So I have minus 150 I delta equals 0. If I got lost and I don't know how to do that, that's okay. I can write one by one. I can write, I think this is a 3. Yes, I'm correcting it. This is a 3. So this is kilo, so it is times 10 to the power 3, and this is kilo, it's 10 to the power 3, but this is milli, it's 10 to the power negative 3. Okay? Now, if I got lost and I don't know how to write that equation, that's okay. There is no need to be scared. What you have to do, you will put signs for each branch. Is this your question? Yeah. Okay. That's why I told you, wait, I know that you will ask about that. So, if you got lost, what you have to do, you will put signs. So imagine, for example, this is my I1, so I'll have positive, negative. And I have a current here, positive, negative. And if I assume that this current is I1 minus 5 milli, I'll have positive, negative. If I kept it as I1 minus 5 milli. But if I used it as I delta, it will be opposite. Okay? So I'll say summation, the voltage is equal to 0. I'll keep the second or the first sign. It doesn't matter. Imagine, for example, I will keep the first sign. And I'm rotating in that direction. So the first sign is positive. The first sign is negative. The first sign is positive. The first sign is positive. At the end, you will have what? Or you will have I1 minus 5 times 10 to the power negative 3 multiplied by 5.4 kilo plus 2.7 times 10 to the power 3 negative 3 times 10 to the power 3, yes. But I can write this since I wrote times 10 to the power 3, so I will change that to be 10 to the power 3. So 2.7 multiplied by 10 to the power 3 multiplied by, here is this, multiplied by I1 plus 1 kilo multiplied by I1, don't forget, minus 150 multiplied by I delta is equal to 0. If you try to compare between this equation and this equation, they are the same. So if you got lost, that's okay. There is no problem. I can write summation the voltage based on the sign for the voltage drop. What is I delta? Actually, I delta is defined here. So I delta is defined as 5 times 10 to the power 3 minus I1. So I can use either the top or the bottom equation. I have only one unknown in that equation, which is I1. Try to simplify that equation. You will find that I1 times 9250 equals 27.75. Then you will find I1, which is equal to 3 times 10 to the power negative 3 amps. Once you got I1, you can find I delta. Because I delta, I can say I delta is equal to 5 times 10 to the power negative 3 minus I1. Based on that, I can say I delta is equal to 2 milliamps. Once you calculated I delta, solving the problem became very easy because you will need to find the voltage between these 2 points for finding the power in this guy. So the voltage between these 2 points is equal to this voltage plus the voltage across this guy, right? So I can say the voltage, imagine that the voltage here is equal to Vs. So I can say Vs equals the current 5 milli multiplied by 10 kilo plus 5.4 times 10 to the power 3 multiplied by I delta, which is 2 times 10 to the power negative 3. If you try to calculate this guy will be equal to 60.8 volts. Now, what is the next step? The next step is to calculate the power across this guy. I have already found the voltage for the independent source, and I found the voltage is equal to 60.8 volts. And this is the direction of the current, and these are the signs for that guy. So this guy is considered as active or passive element. It's active element. So I can say the power for the independent source is equal to V multiplied by I. I is equal to 5 times 10 to the power negative 3 multiplied by V, which is 60.8. Should I add here negative sign? Yes, because it is active. If you try to calculate this guy, it is negative 304 milliwatts. The next step is to calculate the power across this guy. So the power across this guy, if the direction of the current is downward, and the current I1, I have already calculated it. So based on that direction, I can say this guy is dependent or independent source. I can say this guy is active or passive element. It's active element because the direction of the current is from negative to positive, from low to high, which means it's active element. So based on that, I can say the power for the dependent source will be equal to negative 150 I delta, which is the value of the voltage, multiplied by I1. If you try to calculate this guy, it is negative 0.9 milliwatts. So solving that problem is easy if I know how to find summation the voltage for the mesh. If I got lost and I couldn't find summation the voltage for the mesh, use KCL and KVL. That's okay, I will accept it. Any question for that problem? Yes. How did I find VS? Okay, VS is the voltage between those. So I said summation the voltage here is equal to 0. So I can say VS is equal to the voltage across this resistor plus the voltage across this resistor. That's why I wrote it here. It is VI plus IR plus IR. Yes. Yes. It doesn't matter. Yes. Could you please raise your voice?
You said VS is negative and positive, that goes up.
Yes.
How did you
I assumed it is in that direction. And I said summation the voltage here is equal to 0. Let me make this guy bigger here. Let me change the color and show you that again. So if I assume that this is positive, this is negative, this is just assumption. This is positive, this is negative, based on the direction of the current. And if the current is in that way, so I'll have positive, negative. Summation the voltage for this loop is equal to 0. So positive, negative, negative, right? So I can say positive this equals 0, which means this guy is equal to the summation. Sorry, I didn't clarify it. I thought you know how to find it, but that's fine. You got it now? Any question, guys? Okay, let us see another problem. But before moving to another problem, I would like to show you the assignment problem, which is similar to what I did. This one has 3 different mesh instead of only one mesh. I think we solved a problem similar to that before in the first or the second assignment. I don't remember. So the current in this guy is 0. Yes. Then I will say summation, the voltage here is equal to 0. Based on that mesh, I can find the current I delta. Am I right? Based on I delta, I can find this voltage. Then summation, the voltage for this mesh is equal to 0. Summation, the voltage for this mesh is equal to 0. Any question for this problem? Okay. The second problem for the assignment, I'm asking you for that circuit to find Thevenin equivalents between A and B. And then I'm asking you to find V Thevenin by finding V open circuit and solve by finding the resistance by removing this and this, are Thevenin. Do you still remember how to find Thevenin equivalent? For finding VThevenin, I'm finding the open circuit voltage. For finding RThevenin, here he is telling me remove this. It means substituted by open circuit. And remove this, it means substituted by short circuit. And find R between A and B. This will be RThevenin. Similar to this problem, this is similar to what I'm talking about. The only difference here, I'm asking you to find Norton equivalent. So for finding Norton equivalent, I will put a short circuit here, right? And then calculate I short circuit. It will be I Norton. What about R Norton? Substitute this guy by open circuit, substitute this guy by short circuit, and find R equivalent. But if you want to find VThevenin, which is V open circuit, and divide VThevenin over I Norton to find R Norton, that's okay. You got what I mean, guys? Let us see this problem. So I'll copy this one. I have it here. He is asking me to find Thevenin equivalent for question 2. Sorry, Norton equivalent for question 2. So question 2. If you would like to find Norton equivalent, I would like to put a short circuit here. So if you added a short circuit here to calculate I Norton, so I will find I short circuit here. And I short circuit is equal to I Norton. How to find I short circuit, guys? How to find I short circuit in this? Which method you would like to use for finding I short circuit? Which method you like to use? Excuse me? If you try to use node voltage methods, how many nodes do we have? I have this one, and I have this one, and I have this, which is this, which is this, which is this, right? So I will connect all of those to the ground. And then summation the current here is equal to 0, right? Then I will try to find the voltage for this node. After finding the voltage for this node, I can find the current in this branch. How? This voltage minus 0/8, and I have this guy's 4. So the summation of this current plus this current is equal to I short circuit. You got what I mean? So if you would like to use node voltage method, again, what you have to do, you will connect this guy to the ground. Then you will say summation the current for that node is equal to 0. The voltage for that node is 60. I have only one unknown, which is the voltage for this node. So summation the current for this node is equal to 0. This voltage minus 0/8 plus this voltage minus 0/40 plus this voltage minus 60/10. I can solve the problem for finding this voltage. Once you found the voltage, you can find the current in this branch. The current in this branch, which will hit that node, is equal to what? It's equal to this voltage, minus 0 divided by 8. And the current here is 4. So this current plus this current is equal to I short circuit. Yes. Because this guy is short circuited. I don't have any resistor in between. So if this guy is connected to the ground, right? If this guy is connected to the ground, this guy is connected to the ground, this guy is connected to the ground, and this guy is connected to the ground. All of them are grounded. Now I'm looking for what? I'm looking for the current going from this and this to the ground, which is this current, which is equal to this plus this. Yes. Yeah. You're welcome. Any other question? I can solve this problem using mesh as well. We have already solved many problems related to node voltage method. I would like to practice more in solving using mesh. So let us, but I can solve it using node voltage method. And I showed you it's more easier. Am I right? It's more easier to use node voltage method because I have only one equation in one unknown. But I can solve it using mesh. I'll leave it to you to solve it using node voltage method, and you will follow what I said. But right now, if I would like to solve it using mesh, why I'm using mesh for this? Because I would like to practice with you how to use mesh. But it is more easier to solve it using node voltage method. So if I give you a problem like that for the final or the midterm, it's better to use node voltage method. Are you seeing what I'm talking about, guys? But right now, I'm solving it using mesh. Why? Because I would like to practice more in solving using mesh. So I'm going to assume a current in this mesh. What is this current? It's 4. And I'm going to assume a current in this mesh. What is this? I1, it is unknown. What is this? I2 or I short circuit. Actually, this guy is called I short circuit. So this current is I short circuit. I would say summation the current for each mesh is equal to 0. Summation, sorry, the voltage for each mesh is equal to 0. So summation the voltage for this guy is equal to 0. I can say I have 60 volts and I have the voltage drop across this guy and I have the voltage drop across this guy. So I can write summation V is equal to 0 for mesh 1. For example, my son is calling me. I will put the phone away because it's vibrating. So summation the voltage here is equal to 0. I have a current here. What is this current? It is I1 minus, yes, I1 minus 4. What about this current? It's I1 minus I short circuit. So if this is the direction of the current, I'll have positive, negative. If this is the direction of the current, I'll have positive, negative. Right? So based on that, I can say the second sign for this guy is positive, the second sign for this guy is negative, the second sign for this guy is negative. So I can say 60 minus 10 multiplied by I1 minus, yes, minus 40 multiplied by, excellent. This guy is equal to 0. By the same way, I'm going to say summation the voltage for this mesh is equal to 0. So if this is the direction of the current here, this current is equal to what? I short circuit minus 4. If this is the direction of the current, I'll have positive, negative. If this is the direction of the current, I'll have positive, negative, which means this voltage drop minus this voltage drop is equal to 0. Am I right? Because they are in opposite direction. So the second sign here is positive, the second sign here is negative. Summation V is equal to 0 for mesh 2. I can say 40 times I1 minus I short circuit, yes. Minus 8 multiplied by I short circuit minus 4 equals 0. Solve these two equations and you can calculate I short circuit. It is equal to 7 amps. Now, once I calculated I short circuit, I can say I Norton equals 7 amps. After that, I asked you to find R Norton. So to calculate I Norton, I can put this circuit here again. For I Norton, what should I do? What should I do with this? Open this circuit. What should I do with this? Short circuit. So what am I going to do? I'm going to redraw this circuit like that. Am I right? 40 and 8 and 10. Then find R equivalent. R equivalent here equals what? This is R Norton. R equivalent equals what? These two are connected in the overall with 8 in. So I can say 10 in parallel with 40, and the overall is in series with 8. This guy will be equal to 16 ohms. And this will be Norton equivalent. This guy will represent I Norton, which is 7 amps. And this guy is representing 16 ohms, and this is point A, and this is point B. This is Norton equivalent. Any, yes?
And a question when it says show the Norton equivalent, is have to draw that last.
Yes, if I asked you to show Norton equivalent, you have to draw the equivalent circuit, yes.
I drew it like in parallel. I just drew a resistor and called it R. Is that also right?
That's fine. You can write R Norton and I Norton. That's okay. Any question for that, guys? Let us go back to the assignments. This is the tutorial. I think I'm still recording. Yeah. So let us go back to the assignment. I can solve this problem like what I did. If you open this and you short circuit this, what's going to happen to those? Short circuit, so I will cancel them. At the end, I'll have 20 and 60 and 10, right? So 10 will be in series with 20, am I right? And the overall with 60 in parallel. Here I asked you for problem number 3 to find Norton equivalent with respect to the terminals A and B for the circuit shown in figure 3. I mean figure 3, not figure 4. So I would like to find Norton equivalent between these two. So how to find I Norton? I'll put a short circuit, right? And then I will calculate I short circuit, right? Any objection? Yes? Yes, I have dependent sources. So I Norton, since I have dependent sources, I Norton should be equal to 0, and there is no need to calculate it. Since I have dependent sources, I don't have at least one independent. At that time, I can say I Norton is equal to 0, and V Thevenin is equal to 0, and R Norton is equal to Excuse me? So how to find R Norton? Yes, for finding R Norton, what I have to do, I have to inject here a voltage source. What is the value of the voltage source? Any value, and then calculate the current. Or inject a current source here and calculate the corresponding voltage and divide V over I. Right, guys? I told you that before. And this was one of my midterm exam problems. Although I told you, many of you will be tricked and waste their time for calculating I Norton like what he did. Anyone here? Yes.
So if A and B get exactly the get rid of this, but this is different because it's longer.
Yes. Any question, guys? I'm not hearing what they are saying.
What do you do with the dependent
Who's talking? Yes.
What do you do with the dependent sources? You insert a voltage across AB.
Oh, if you have a dependent source here, to solve the problem, what you have to do, you will insert here, for example, 10 volts. And then you will calculate the corresponding current. And then R Norton is equal to 10 over I. That's it. I will calculate I. Or insert 100 volt or 1000 or any value. Okay, or insert a current source and calculate the corresponding V. For this problem, I told you the variable resistor in the circuit 4 is adjusted for maximum power. Find RO for the maximum power and find the maximum power. This problem is similar to this problem that I'm going to solve it, which is problem number 4. So problem number 4 here in the tutorial, I'm saying the variable resistor in this circuit is adjusted for the maximum power. Can you please find RO for the maximum power? Can you please find the maximum power? But this problem is more harder than the assignment problem. I'll show you why. But before I start solving this problem, I would like to solve this problem as an extra practice. For the following circuit in figure 3, yeah, we have already solved this. Calculate the current in 10 ohm resistor using Thevenin. So here in this circuit, I'm asking you to calculate the current in this guy using Thevenin. So I didn't ask you to find Thevenin, but I asked you to calculate the current in this guy. But I forced you to use Thevenin. You can solve this problem for finding the current in this guy using node voltage method, using mesh, using superposition, using whichever you want. But here, I asked you to use Thevenin equivalent. So you have to follow me. Right? If you solve the problem using mesh, 0. Why? Because I didn't ask you to use mesh. If you solve the problem using node voltage method, 0. I'm testing you on Thevenin. So you have to find Thevenin between these 2 points. So what am I going to do here? I'm going to copy the problem and then start finding Thevenin equivalents. This is the problem that I'm asking about, and I will try to find Thevenin equivalent. I'll show you how to find it. Question number 3. So what is needed? I would like to find Thevenin equivalent between these 2 points. What should I do, my friend, for finding the Thevenin? Yes, I have to remove this guy first. So I will redraw the circuit again, but instead of redrawing the circuit, I'm going to insert this guy here. It will consume my time if I redraw the circuit. So I inserted this guy and then I will hide it. Okay, then what is needed? I would like between these 2 points to calculate what? To calculate the open circuit. This is to calculate the Thevenin. So what I need for calculating the Thevenin, I need to find the voltage between this point and this point. Right? So the voltage between this point and this point is equal to the voltage across 5 and 5. Maybe summation or subtraction. It depends on the direction of the currents. So how to solve the problem for finding the current in this guy and finding the current in this guy. Because if I found the current in this guy and I found the current in this guy, I can find V Thevenin. So how to solve the problem for finding the current in this guy and this guy? Which method you like to use? Excuse me? Use what? I can use mesh current. But here, if I try to use mesh current, I have 1, 2, and 3. Right? Yes, I have 2 because of the super mesh, or I can use low voltage method. Whichever is more easier for you, use it. If you decided to use mesh current, at that time, I have a current in this guy. Imagine which direction you like, clockwise or anti-clockwise. Clockwise, so this is the direction of the current. So this is I1. This is the direction of the current. And this is the direction of the current. This current will be I2. Yes. This current will be yes. But I have relation between I3 and I2. I2 minus I3 or I3 minus I2 is equal to 2. Which is which? I2 minus I3 is equal to 2. So I can say I2 minus I3 is equal to 2. Based on that, I can say I2 is equal to 2 plus I3. Please, from the beginning, substitute this guy by this. Because if you didn't do that, you will have 3 equations in 3 unknowns. And I don't like to see 3 equations in 3 unknowns. That's why if I'm writing summation of the voltage for each mesh is equal to 0, let me start by this. Summation of the voltage for this mesh is equal to 0. So summation V is equal to 0 for mesh 1. So here I have this voltage, which is positive, for example, positive, negative, and for this guy, I have positive, negative. So I can say the second sign here is positive, negative, negative. So based on that, I can say 10 minus 60 multiplied by I1 minus I2 minus 20 multiplied by I1 minus I3 is equal to 0, right? And then summation V is equal to 0 for which mesh? This mesh? This mesh? Am I right? But the problem is I don't know this voltage. Okay, so this mesh, should I use this one? I still have the current, so what should I do? I can use super mesh. For the super mesh, let me change the color. For the super mesh, I can use different mesh. Like for example, I can use this guy or what else? Yes, I can use this guy. This mesh. Or I can use, follow me, I can use this, 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 this. You got it? So let me erase this. I can use this guy. Am I right? So I will say summation the voltage for that super mesh is equal to 0. What is the current in this guy? I3. So I'll have positive, negative. What is the current in this guy? Yes, I2, positive, negative, then I2 here, positive, negative. Then summation V is equal to 0 for the super mesh. Are you seeing this color? So what I have here, I will keep the second sign or the first sign, it doesn't matter, as you like. This is the second sign. 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 Am I right? Now, I will say 20 times what? Yes. Is it right? And then for this guy, I will say 60 times I1 minus I2. And then for this guy, the second sign is negative, 45 times. And then for this guy, 5 times I2. Did I miss anything? This guy will be 5 times I3 is equal. Please don't forget I2 substituted by 2 plus I3. I2 substituted by I2 plus I3. Sorry, substituted by 2 plus I3. 2 plus I3. I2 substituted by 2 plus I3. I2 substituted by 2 plus I3. Then you have two equations in two unknowns, this one and this one. Solve them and find what? Solve to calculate I1, I2, and I3. If you found I1 and I2 and I3, what do you want? I would like to find the voltage between these 2 points. So I will put this voltage in this loop. I will imagine I have a loop here, and I will say summation the voltage for this loop is equal to 0. If I'm moving clockwise, the second sign is positive, positive, negative. Then I can say V open circuit is equal to the summation of those 2 voltage drop. So V Thevenin is equal to V open circuit is equal to 5 multiplied by I3 plus 5 multiplied by I2. This will be your V Thevenin. Are you seeing what I'm talking about, guys? Any question? Yes. Go ahead. Yeah. Yes, I'm seeing you, but I'm ignoring. Could you please repeat? Please stop talking.
Can you please go over how you got 6 I1 minus I2?
60 times I1 minus I2. Where's 60? Yeah, this is 60. The current in this guy, which is the current in the common branch between this mesh and this mesh. So the current, if I assume that this is the direction of the current, it is in the same direction of I1 and in opposite direction of I2. That's why I said the current here is I1 minus I2.
Are you not moving?
It doesn't matter. I'm moving anyway. So here what I said if this is the direction of the current, at that time I'll have positive here and negative there. Then I'm choosing if I'm rotating in that direction. The second sign here is positive, the second sign is positive, the second sign is negative, the second sign is negative. You got it? So 60 times I1 minus I2, its sign is positive because I'm rotating in that direction and I'm keeping the second sign. You can rotate in any direction, keep the second or the first sign, it doesn't matter. You got it? Yes.
You mentioned earlier
Yes.
the current source. Or
Current source where?
like between the mesh of I1 and I2, the same way you have I3 and I2.
Yeah, I said I can use this outer. It will create another equation. This outer loop, right now, I'm not talking about this mesh, I'm talking about the outer loop. Okay, yes. Yeah, go ahead. That's okay. This is a closed loop or not. If this is a closed loop, that's okay. Any closed loop is working. So if I have any closed loop, I can say summation the voltage for that loop is equal to 0. Yes.
Yeah, I want to know, like,
Sit down where you are standing.
that the wire
Okay.
I want to know how you get that I2 equals.
Okay, how I got I2 equals to 2 plus I3. Where is I2? Yes, this is I2. If you try to see here, this branch is a common branch between this guy and this guy, right? So the direction of the current that I assumed here is in that direction for this mesh. And the direction of the current for this mesh is in that direction. So this guy is in the same direction like that, but in opposite direction to that. So it is the difference, right? So the current in this branch, the difference between those, is it I2 minus I3 or opposite? It depends on the direction of this guy. This guy is in the same direction of I2. That's why I said it's I2 minus I3. Excuse me? So it is I2 minus I3. But if you want, you can find it from here. Summation the current for this node is equal to 0. Right? If this guy is I2, am I right? And this guy is I3. And this guy is 2. So I2 is equal to the summation of this plus this. You got it now from that node? Any other question? Yes. Okay. We are talking about this part. So this is 5 ohm and this is 5 ohm. And this is the open circuit that I'm looking for, right? The direction of the current here is in that way, and this is the direction of I3. And then I have the rest of the circuit. Okay? Now, I'm going to imagine that this is a closed loop. So this is the direction of the current, so I'll have positive, negative. This is the direction of the current, I'll have positive, negative. Summation the voltage for this loop is equal to 0. Imagine I'm rotating in that direction. The second sign is positive, the second sign is positive, the second sign here is negative for this voltage. So I'll have positive, positive, negative, which means this guy equals the summation of those voltage drops. Got it now? Any other question? Let me talk about the last part, which is how to calculate R Thevenin. So to calculate R Thevenin, I will redraw the circuit again, which is this circuit. And what is needed? I have already removed this guy, right? And what should I do with this? It will be open circuit, right? And this guy will be, so I will redraw that. This guy will be short circuit. So this guy will be open circuit. I will draw that guy, 45. This guy is 60. This guy is 20. This is 5. This is 5. And this is opened. And I would like to find R equivalent. Am I missing anything? Any question for that equivalent circuit? Now, these two are connected in. And the over all of those with this guy in. Oh, this is short circuit. So no need for those. Right? So the new circuit will look like what? Will look like this guy. Now I have 45. I have 5 and 5. 5 and 5 are connected in the over all of those with this one in. So I can say that R equivalent equals 5 plus 5 in parallel with 45. It will be equal to 10 times 45 over 55, which is 8.2 ohms. Once I found that, I'll go back, redraw my circuit again. This is the Thevenin. This guy is R Thevenin. And this guy is the resistor that I have already erased, which is 10. I forgot what he was asking about. He was asking about the current in 10 ohms. So once I reach it to that point, I can say the current in this guy, I, this is Thevenin equivalent. The current I is equal to V Thevenin divided by 8.2 plus 10. You can calculate it. Any question for that problem? Let me solve last problem because you would like to leave. Last problem, I'm going to solve it, which is similar to the problem in our assignment, which is this problem. So he gave me here, for this problem, he said the variable resistor in figure 4 is adjusted for maximum power transfer to RO. Find the value of RO and find the maximum power. So for solving this problem, what I have to do is I have to find Thevenin equivalent first. This problem is a good one because we never see problem that has voltage source connected between these 2 points. Right? Let us see how to solve that problem. So the first step for solving such a problem is to find Thevenin equivalent. How to find it? Let me go back, copy this circuit. I know that you would like to leave right now. I will finish this within like 10 minutes. And we will leave early. So, question number 4. This is the circuit that I have. What do you want to find? I would like to find V Thevenin. So what should I do for finding V Thevenin? I will open this circuit, so I will not redraw this circuit. I will insert this guy here. I'm showing you some technical parts to use it. So I will open this circuit. Now, I would like to calculate the voltage between these 2 points, which is the open circuit. Now, this problem is a good problem because many of you will say that the open circuit is this voltage, right? But it is not right. The voltage between these two is this voltage and this drop. Maybe I will add them, maybe I will subtract. It depends on the direction of the current in this guy. So I can say that the voltage between these 2 points is equal to this guy plus or minus this guy, but I have to define first the direction of the current in this guy. Imagine, for example, this is the direction of the current. So I will say I'll have positive negative sign here. If I put this, you were asking me about how did I get V open circuit. Someone in the back, I think you, right? You asked me how did I get the open circuit. So this is similar to what I said. So I'll say summation the voltage for this loop is equal to 0. I'll put this guy in a loop. Summation the voltage here is equal to 0. So if I'm assuming that I'm adding in that direction and I'll keep the second sign. The second sign is positive, the second sign is negative, the second sign is negative. Am I right? So I can say 10I minus 10 minus V open circuit equals 0. Based on that, I can say V open circuit is equal to 10, right? I minus 10. Am I right or wrong? So what is needed? I would like to find the current in this guy. My question right now, are you expecting there is a current here? So why there is a voltage? Since there is no current, why there is a voltage? Excuse me? I'm not hearing.
There could be potential difference across your current.
Okay, but there is no current. Why there is voltage? The answer is, he said it, but in a different way. If you try to look to this outlet, or this outlet, there is a current here? No, I'm touching it, there is no current. But if I try to bring multimeter, am I going to measure voltage? So for any open circuits, if you have a battery, there is a voltage. But there is no current because there is no closed loop. So if you would like to find the voltage between these 2 points, you have to keep this in your mind because there is a battery. There is a voltage between these 2 points, but there is no current here because this is open circuit, like the outlet that I showed you. So what is needed right now, I would like to calculate the current in this guy. First, how to calculate the current? There are different ways for calculating the current. I can say summation the voltage for each loop is equal to 0, right? Or I can use node voltage method. What is the easiest way to find the current in this guy? What is the easiest way? To use node voltage method, I believe, because for node voltage methods, it's very easy to say summation the current for this node is equal to 0, and summation the current for this node is equal to 0, right? And actually, I don't need this node because there is no current in this guy. But here, if you try to look to this problem, did I ask you about this branch to calculate anything for it? Can I convert it? I think if I converted it from current source to voltage source, it will be more easier to solve the problem. Because I will minimize the number of nodes. If not, there is no problem. That's okay. I will assume I have voltage here. Its name is V1. And I have voltage for this guy. Its name is V2. Right? Do I need this guy to be node? Why no? Because the current in this guy is the same like the current in this guy. So those two are connected in series. So I will say summation the current for this node is equal to 0. Summation the current for this node is equal to 0. Because if this guy is I, this guy will be I. And don't say, oh, we have here this branch. Yes, but there is no current. There is a voltage, but there is no current. So based on that, I can add those two. And I can say they are connected in series because there is no current here. So summation the current is equal to 0 for node 1. This current plus this current plus this current is equal to 0. So negative 3 milli plus V1 over 4 kilo plus V1 minus V2 divided by 8 times 10 to the power 3. This guy is equal to 0. Then summation the current for node 2 is equal to 0. So I have this current, and this current. This current is V2 minus V1 over 8 times 10 to the power 3 plus. This current is V2 minus 10 divided by 20 kilo plus this current, which is V2 minus 0 divided by 12.5 times 10 to the power 3. Solve these two equations and try to find the voltage V1 and V2. If you try to solve these two equations for finding V1 and V2, you will realize that V2 should be equal to 7.03125 volts. If you found V2, you can find this current. So I can say the current I is equal to V2, which is this current, divided by 12.5 times 10 to the power 3. So this guy will be equal to, you can calculate it. I didn't calculate it here because I jumped at that step and I found this voltage by saying that V open circuit, I assume that this is I1. Oh, it's I. Why I'm writing here I1. Okay. So based on that, I can say V open circuit is equal to 10I minus 10. If you try to calculate it, it will be equal to negative 4.375 volt. Based on that, V Thevenin should be equal to negative 4.375 volt. Oh, I got V Thevenin with negative sign. Probably it is not right. Is it right to be negative? We didn't get anyone negative before. Flip your sign. That's okay, acceptable. This is the wrong sign. You can flip your sign, positive to be negative. That's it. This is your V Thevenin. Now, the last thing is I asked you to calculate R Thevenin. So for calculating R Thevenin, what I have to do, I will remove this guy, right? So to calculate R Thevenin, so I will open this, and this guy will be, and this guy will be, and this guy will be open circuit. So if you try to redraw this circuit again, it will look like that. This will be R Thevenin. So this is 10 kilo, this is 2.5 kilo, this is 20 kilo, this is 8 kilo, this is 4 kilo. Now, these two are connected in the overall of those with 20N. So those are series. The overall is in parallel with 20, and the overall of those is in series with 2.5, and the overall of those is in parallel with 10. So I can say R equivalent is equal to 4 plus 8 in parallel with 20, and the overall in series with 2.5, and the overall is in, yes. If you try to calculate R equivalent, it will be equal to 5 kilo ohms. Based on that, I can say for max power, RO equals R Thevenin equals 5 kilo ohms. And if you would like to find P max, I can say P max is equal to V Thevenin square over R for R Thevenin. So this guy will be equal to 957 microwatts. This is the last problem in the assignment, but before leaving, I'd like to show you the last problem in the assignment. This is the last problem in the tutorial. I'd like to show you the last problem in the assignment, which is this one. I asked you here to solve this problem using mesh, and then I asked you to solve it again for finding IO by using superposition. So by using superposition, what I have to do, I will use this only, and those two will be zeros. So this guy will be replaced by open circuit, this guy will be replaced by short circuit, and then find IO due to that guy. Then remove this and keep this. So this will be open circuit for the next step, and this will be open circuit, and I will use this only for calculating I for the next stage. Then for the last stage, this and this will be zeros. So this is short, this is open, and I'll keep this, and I'll find I here due to this guy. Then I will add all of them to find the total current I. Do you have any question for that problem, guys? Excuse me? Could you please raise your voice? Oh, you need this page? Okay. Okay, thank you so much. I'll see you all tomorrow. Please don't forget to come tomorrow, because the Associate Dean office would like to talk with you about something. I don't know what is that. I'll stop recording and I'll go back